All right. Good afternoon, evening, whenever you are viewing this, everyone. I wanted to make this just kind of as an addendum to what we're going to be going over tomorrow. So I'm recording this on like the 11th, so Monday. We're going to go over this in class Tuesday. But I just want to have this, as a video source for you all later. Um, just something that I saw while grading the quizzes is a lot of us really had problems with the density calculations, and as such, I did not grade that question, um, except for the honors class because they should have known that, and most of you did. But I want to just go over really what I'm asking for everyone, and then I'm going to also talk about dimensional analysis, just in a way that if this makes more sense to you, use it. Um, so up here I have my density formula. Boom, 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 density formula. And the questions that I was really asking for on that quiz was really, let's see, right? If I give you a value, so let's say I say that you have a piece of metal and its mass is, in this example, let me clear this. In the example that I had on the quiz, it was the volume equals 100 milliliters. Right, it was an unknown sample, and I perhaps I should have specified that better, and I apologize for that. Um, but if this was a completely different example, right? So you took the density from your calculations, from part one and two of that question. It should have been 21.19 grams per milliliter. That's what we should have gotten. And basically, the question was asking for what is the mass? If you have this sample, what is the mass? And you'll see a question like this on our test. So that's why I really want to go over it, because I will definitely be grading it on the test. Um, so one way to do this, which I think might have been actually a little bit easier, is to basically algebraically solve this equation. So when you have the line here, I just want to start very basic here. This is a division, right? So if you have this is 4 over 5, right? This is division. 4 divided by 5 would give you 0.8. And then units. I'm not using these units. Right, so this this is what a formula means. Like these types of formulas. Erase through here. So when you have a formula like this, these are variables that mean something. Excuse me. So this is the density. This symbol represents our density value, right? And I have this up here. This is what our density represents. This M here represents mass. So you will put in a mass into here. So you should know what units mass is made out of, or what units go with mass, right? That's when we took the scale, and we put our metal on the scale. That was in units of grams. Volume over here, that is how much space something takes up. So when we calculated the graduated cylinder, right, it was the thing that kind of looked like this, and it had all these like little lines, right? That thing. That was telling how much space that water was taking up. It is calibrated to be exactly that much amount. So that is not dealing with mass, that deals completely with volume. How much space something takes up. That's like three-dimensional space, like length times width times height. That's how you get it a rectangle, but it's a lot harder when things aren't rectangular like that. So when you have a formula like this, you're going to need to solve the best way to try to really do this Figure out which of these variables you already have information on. So I've given you this information. The volume is 100 milliliters of this unknown metal. And your density, this is what you calculated in the previous part. If you had gotten that wrong, that density wrong, and let's say your density was zero point 0.2 grams per milliliter, if you still use this value in this equation and you show me that, you will still get full credit. I don't penalize you for getting this answer wrong, which means you automatically get the next wrong answer wrong. That's just insane. So what we can do here is we can solve this algebraically without even putting in the numbers, and I think that might make things a little bit easier. So what we can do here, if we want to get the mass, we need to isolate this variable. So how do we do that? We solve algebraically. We multiply each side by the volume here, and we now have a volume on top. This is a variable. It would just be like having like mass times x over x. Those x's would cancel each other off. So this volume cancels out, and we're left with mass. But now we still have volume times density. So volume multiplied, and there is a multiplication here, equals mass. Now you can plug in your numbers. So where V is, you put 100 milliliters. I'm just going to draw an arrow to show where I'm going. Multiplied by this number here, which is 21.19 grams per milliliter. And if you do it like this, you can even see the units cancel out. You have milliliters on top, milliliters on bottom. It works, easier this way, where you solve the equation first, and then you plug in the numbers, and then you replace the variables with the values. So you can multiply this, and this would give you, so 100 times 21.19, 2119 grams would be your answer. So I want to go over how would you get it if I gave you, let's say, a mass equals 5 grams and a density equals 4.5 grams per milliliter. How would you solve this then? Well, and I want you to find the volume. So first, you realize what numbers do we have? What are you trying to solve for? You're trying to solve for volume. So we need to isolate this volume. This is going to take a little bit more algebraically. We can do the same thing that we did last time. Let me erase here. We can do the same thing that we did last time. Multiply this by V. Multiply this by V. And we get V times rho, volume versus density equals mass. But now we need to get rid of the density. We need to isolate this V. So we can divide by density on both sides. This gets rid of the density, and your new formula is volume equals mass over density. So then once you've got your values in, you've got your formula done, you put your values in. Volume equals 5 grams divided by 4.5 grams per milliliter. This grams cancel out. This milliliter will actually flip to go on top. Don't worry about this too much. You should know what the units of volume are, so you should know that your answer should be in milliliters. And then you would take 5 divided by 4.5, and that will give you your answer. So I can... Oh, it completely gets rid of my work when I change. Okay, awesome. So it was, so your mass, sorry, let me just redo this here. Say mass was 5 grams, density was grams per milliliter. And we had volume equals mass over density, which was 5 grams over 4.5 grams per milliliter. And then we solved this was 1.11 milliliters was our answer. All right. The final thing I just want to go over is dimensional analysis. I saw this way of how to like write this on a TikTok, and if this makes more sense to some of you people, some of you guys, oh my God, I sound weird as hell. If this sounds like it would work better, then use this method. I just wanted to put it out there. So when you're trying to convert, let's see, what's an example? I know I had that I actually know 1 mile equals 1.61 kilometers. I just graded your quizzes, so I feel like I should have memorized this by now. Right? And if I said, okay, I want to get 32 kilometers into miles, right? Like this is what I'm trying to solve here. This one way that I saw how you can do it is basically you take your 32 kilometers and you make a almost like a box like this. You do 32 kilometers and then um you put your conversion factor down bottom and like this. And basically the reason that they do it like this is to really show you that this is on the top. I'm gonna, like this is on the top right here. This is on the bottom right here. Top, bottom. It makes it like you don't have to worry about the multiplication and you just put everything on top, all your top numbers on top, everything else on the bottom. So now that we have the kilometers on the top here and it's cross from here, it's on the bottom, they cancel out. And basically, when you have the different, like this, where I'm circling here, this is your key to multiply everything on the top. So you multiply through on the top. 32 times 1 mile. Right? So you multiply by every single number here on the top. And then you divide all this stuff by the bottom numbers. You do the same thing with the bottom numbers. If you had like a 4 here, right, you do 4 times 1.61. But we don't. I don't know if this helps anyone, but if you want to write it like that, go ahead. It might just make things a little bit easier for your organization rather than having all these multiplications and, oh, where's the division? And there's no division sign over your initial thing. Whichever one works best for you. All right. So that's just a quick update. Um, I just wanted to uh, kind of go over. Hopefully that helps. Good luck.